This video is going to demonstrate some math tools that we can use to evaluate limits analytically. So you see them here, A through E. I'm going to keep the video moving just for time's sake, but you might want to pause it right now to copy down this list in your notes. The first is substitute and evaluate. So we see a limit here, and again there are a lot of different ways to evaluate a limit. But the easiest way is just to plug it in. So as we notice here, if we plug in a 2, we get 4, 8, plus 1 is 9, over, and then if we plug in a 2 down here, we get 4 plus 12, so we're at 16, and then 16 minus 4 is 12, so our limit is 3/4. So that is the first thing you should try on any limit problem, just because it's the easiest and it'll save you a lot of time if it works out. Okay, the next one is to simplify and evaluate. So let's take a look at one of those. So we have a binomial here that's being cubed. So we could take some time and multiply 2 plus x times 2 plus x, get that answer. And then multiply that answer times another 2 plus x. We're just going to take a minute here to remind ourselves of binomial expansion and Pascal's triangle. So here's personally what I would do to get through that binomial. And here's that minus 8 at the very end of the limit, and that's all going to be over x. So just check out the exponents here. Hold on a second. 0, 3, 1, 2, 2, 1, and now we're at 3, 0. And with Pascal's triangle, because we're at we're cubing this binomial, we're going to use this list of coefficients, and those belong a little faster than expanding out the binomial the long way. Alright, so as we simplify this, we'll have x cubed plus 2 to the first times 3. We're at 6x squared. We're at 4 times 3, which is 12x, and then 8 plus 8. Then we have this minus 8 over here, all over x. Technically, I should still have my limit notation here, so I'm going to get that in to make it proper. Okay, and I'm going to remember it this time. Alright, let's take a look at what's happening up here. These 8's are canceling to 0, and that leaves us with 3 terms up here, which each one can be divided by x. So we're gonna take those 2 steps in one. These are gone, canceled, 8 minus 8, and divide by x. So we're at x squared plus 6x plus 12. All right, we've simplified that. Now let's evaluate. We're going to plug in a 0 and get an answer of 12. Alright, the next one is to factor and simplify. So let's take a look at that example. Alright, so we have a trinomial divided by another trinomial. The limit as x approaches -4. Most of us, when we see a trinomial at this point in calculus, we're tempted to just factor that. So let's take a minute to do that. And we're looking at x plus 4 and x plus 1, and down below factoring x plus 4 and x minus 1. So our quantities will cancel. Now let's look at the limit as x approaches -4 of x plus 1 over x minus 1. And again, we've simplified this. Now if we think about evaluating this limit, we have -3 over -5, and so our limit is 3/5.